taking a look at to see how to determine whether or not this series converges or diverges. So let's begin. So first let's take a look. So it's asking you what to determine whether the sequence of 1 over square root of n squared plus 5 is convergent or divergent from n to infinity. Okay, so first we'll have to take a look at, we can do the divergence test. If we do the divergence test, we find out that the limit as n approaches infinity is equal to 0, thus it comes back inconclusive. So we'll have to try some other test. And when I first see this problem, I want to compare it to something because of this square root. It's not really a good way to get rid of that using the tests. So let's then compare this to 1 over the square root of n squared. Let's get rid of that pesky little plus 5 because that we don't really need that. That's just going to complicate the whole entire thing. So if we're going to be doing, once we're going to be doing the limit comparison test, not the direct comparison test, because then we would have to prove that that one is larger than that one and all that fun stuff. If we just do the limit comparison test, we can just compare these two. So then we'll take the limit as n approaches infinity of the square or absolute value of 1 over the square root of n squared plus 5 over 1 over square root n squared. Absolute value closes up. So then we get the limit as n approaches infinity of 1 over the square root n squared plus 5 times n squared, square root of n squared over 1. And I just simply multiplied by the reciprocal of this to just get that. And if we take a look at that, the ones will cancel each other out. So then we just get the limit as n approaches infinity of n squared over n squared plus 5. Okay? And if you take, if you replace n with infinity, you'll see that that goes to infinity and that goes to infinity. So this is equal to infinity, which by the limit comparison test rules, this series would diverge. Thank you.